Guten Tag, mis amigos. If you don't know me already, my name is Kyle Koberly, and I am going to teach you about Docker today. Specifically, by the end of this, you should be able to describe Docker, and you should be able to build and run Docker containers. That's enough to be dangerous with. So, describing Docker, there aren't a whole lot of technologies that I'd recommend learning from like the ground up. Really, there's only two: Git and Docker. Everything else, use it, figure it out. You'll build a better schema for how it works that way than anything else. Docker, you're probably not going to get very far if you don't get how it's kind of structured internally. So to do that, first we have to understand a thing or two about operating systems, specifically the Linux operating system, but this is pretty broad. So on your computer, you've got some hardware pieces. You have the sticks of RAM, you have a processor that's like crunching numbers, you have a hard drive, you have a network card, you have all these different kinds of things that are specific to your computer. And the code needs some way to access those resources. It needs to say, hey, I want to save a file. Hey, I want to crunch some numbers. So the thing that manages all of that communication is called a kernel. And really, that's like specifically what Linux is. People use Linux to describe like kind of this whole stack here. But the thing that Linus Torvalds and co. work on is this like hardware communication piece. And then the thing that like we would call the operating system, where it's like running applications and you run your text editor and your like CD and MV and LS commands on the terminal. That operating system stuff in Linux land, that's GNU. And what that's doing is making system calls to the kernel. So you say, I want to save this file over here in the operating system. That makes a system call to the kernel saying, hey, can you figure out how to save these ones and zeros to this hard drive? And the kernel translates that for you. And then there's another GUI layer on top of this. So if you're like Linux, there's so many of them. There's Ubuntu and Fedora and all of these different things. Most of those are the same operating system, and all of them are the same kernel. So even though it seems like there's a ton of different versions of Linux out there, a lot of them up here, really only one down here. And this same principle also applies to Windows and Mac. These are computers. And so if you've done something like work with virtual machines or fake computers of any kind before, usually what they're doing is they're taking this entire stack and making fake copies of it. So you have fake RAM and a fake CPU and a fake hard drive and a fake kernel. So if you're running like Mac OS on Windows, or you're running Windows in a VM on AWS, it's like all of these things. And usually what it's doing is carving up part of your computer, like taking one of your processor cores, 2 gigs of your RAM, and like allocating them for this fake computer. And it's pretty heavy because translating all of this from like a fake computer to a real computer in real time is pretty intense. And so that's what's happening here. In contrast, the thing that makes Docker so special, Docker is running on your operating system and has a lot of the benefits of this, but it doesn't have a full fake computer that it's working with. What the Docker engine lets us do is make those system calls to the kernel directly. And so you have a container, which is like a fake operating system. And you're saying, for this fake operating system, I wish it had Python, this version installed, these different dependencies and utilities. I wish it had these files copied into it. And then you can run those applications completely isolated, not only from other Docker containers, but from your local operating system. And you're letting it make the system calls directly. So you could have an arbitrary number of these containers that are arbitrarily complex, And they're just using the same resources that everything else in your computer does without worrying about any kind of cross-pollination. And the most powerful thing about this is this Docker container that has all these dependencies and all this code and all this stuff on it, and it works okay on my computer. If it works okay on my computer, it'll work exactly the same on yours. It'll work exactly the same on AWS's, on GCP's, because this container, this is the metaphor that they're trying to evoke. It's like a shipping container. It was in this port and went on these trucks and went on this ship and whatever else, but it's the same container everywhere. So anything else that also has a Docker engine, this is different than the desktop environment that I'm referring to there. Anything that has one of these Docker engines, if you put that container on it, it runs identically because those system calls are going to be the same regardless. So like it would be pretty tricky to run 100 virtual machines on your computer because at some point you run out of like CPU cores to carve up and RAM to siphon off. With a Docker container, you're really only limited by how fast your computer is. And they're way lighter weight, so they're faster, more efficient. On Linux specifically, if you are running Linux as your working operating system and these Docker containers are always Linux, there's almost no performance hit at all. On Mac, we're actually running a virtual Linux machine that these are running on top of because Docker Engine only runs on Linux. So really, on Mac or Windows, we do still have to run it on a VM, but they are super duper optimized to try to be as efficient as possible. So when you, if you installed the Docker engine from like the Docker desktop from the Docker website, like this, you went over here and downloaded all this stuff. What that actually is a VM that runs on Mac and Windows and supports Docker Engine. Docker Engine itself is open source. If you're on Linux, you just pull it down for free from the repositories. If you're on a different operating system, we got to have a way to run that. So Docker Engine is the most popular way to do that. Worth noting that it's a commercial product. There are like some licensing concerns with for-profit companies using it, et cetera, et cetera. But when we're trying to think about how this fits into an application ecosystem, a VM is a fake computer, a Docker container is a fake operating system. And so to get more concrete, this is what a Docker file looks like. We're saying, I want to take a Linux computer that has Node 20 installed on it already. I want to set the folder that I'm in right now, it's like a cd command basically, to /app. I want to be the root user. I want to copy these two files from my like actual computer's operating system into this container. I want it to run npm install. And so it's going to install all those dependencies into the container. And then I want you to copy the rest of my application files into that container. More later on why we do those as two different steps. And then I want you, this is like the start command for my application. So, so this becomes, this Docker file gets built into an image, and then we can have a bunch of instances of that image, which are containers. And so every one of these containers will have all those dependencies, is using all of those specific versions, and then we can pass them back and forth between each other, rebuild them, all that kind of stuff. And so we've kind of achieved our infrastructure as code thing in a way lighter way than trying to describe the entire computer that they run on. If you have more than one Docker file, there's a tool called Docker Compose that says, all right, I want this container to talk to these containers, which talk to these containers. Some of these are like commercial ones. So like this one in particular is a Docker container that has Playwright and all of its dependencies and all of its browsers and all of its goofy config stuff already set up, just waiting for your tests. You can say, I want to expose these ports from the container to the rest of my operating system. You can say, I don't want to just copy these files from my computer into the container. I want them to actually read live. So like it's a file system that's shared between a Docker container and my computer. So we have some pretty cool options for how these things communicate between each other also. And we can really describe pretty complex applications this way in like mega repeatable ways. Another way to think of this is imagine it's your first day on the job and you go, all right, I want to get my local development environment set up. And you pull down the repo and you run Docker Compose up and you're done. Everything else lives in the containers. There's nothing to install locally. So hopefully that gives you some ideas of how this whole ecosystem sort of fits together. So going back to our objective, first objective for Docker 101 was describing Docker. I would like you to do your best job to do this. You can say it out loud, you can say it to a buddy, you can type it out, but I want you to actually use the neurons because there's a pretty good chance that you followed along step by step with everything that I said, and you went from here, followed me to here, followed me to here, followed me to here. And what I need you to do now is to try to do this entire thing on your own. So pause the video and give me your best description of Docker. Okay, so hopefully you've unpaused the video and you actually did the exercise. And hopefully your answer sounded something like, Docker is a way of having a fake operating system that packages code and dependencies and applications and stuff together in a like reusable, shareable kind of way. It's much lighter weight than virtual machines because it's a virtual operating system, not a virtual computer. They share resources with the computer that they're running on, but a Docker container that runs on Docker Engine will run exactly the same on every other Docker engine also. All right, conceptually, that's what Docker is. We can describe what Docker is. Let's get our hands dirty and actually build something. So if you're on Mac OS or Windows, you should have installed Docker Desktop by now. It looks kind of like this. And it gives you some cool tools for visualizing the images. These are kind of like templates. And the containers, those are each instance of that template. Volumes are like your stored data from the containers. This stuff is kind of neat. I never use it. And most people don't, I would say. All you need to do is start Docker Desktop and let it run in the background. It's got a little whale or a container ship icon with a little whale tail on it. Yeah, there it is. So as long as that's running, that's kind of all you need. Most folks work with Docker directly on the command line. So let's make another Docker practice. So go ahead and make a folder anywhere on your computer. I'm going to call this one Docker Practice 2. And nothing up this sleeve, nothing up this sleeve. The first thing that we're going to do is just take somebody else's Docker container and try to run that locally on our computer. So there's one called Hello World that, unsurprisingly, just shows Hello World on your desktop. Lets you know that you have Docker set up correctly. So we're going to run the Docker command, and we're going to pull down the Hello World image. So I think mine was cached already, so it's probably so it went pretty quick. Yours might take a little bit longer. And then if I do Docker run, hello world. Hey, cool, that message shows up. That means that everything's configured right. If yours didn't show this, then it's not configured right. Drop me a line, happy to help. So some things that stand out to me about this. A, that was really easy. B, I don't even know how this was done. This might have been a shell script. This could be Python. This could be Ruby. Who cares? It's going to run the same on my computer as if I deployed this to an EC2 or something like that. And so I've packaged the application code and all of its dependencies together in one thing, and I can run it anywhere. So where did all this come from? That same commercial group that makes the Docker desktop, they also run like a GitHub-like thing called Docker Hub that has all these containers in it. And it looks like this. So when you publish an image on here, which optional, it's just like GitHub, it's a way to move Docker images around, not the only way. But a lot of like the pre-built Docker containers you use, like something that already has Node configured or already has Ruby configured or whatever, are going to come from Docker Hub, and they'll look kind of like this. And so if I want to figure out what the hell I just ran on my computer, tags are kind of like versions. And so each one of these is a different version of this app. And so the one that has the nickname latest, if you don't specify, it'll go with that one, which is probably this one. And if I want to see the actual Docker file, there it is. So what this did is it pulled down this operating system and then whatever other dependencies they've added on top of it. It copies that file into the C drive. Oh yeah, this is like a Windowsy kind of one. And then runs that. I had no idea. Doesn't matter. That's the reusability part of it. So what if we wanted to make our own Docker container? How would that work? So if we go back over that folder, that folder that hopefully you started, clear all that out. Let's make like a super simple Node app. So I'm just going to make an index.js file. And I'm going to make my own hello world. I'll do some Node-y kind of stuff. Like print message, and that takes in a message. That takes in a message, and it console logs it. And I save a message in a variable. Just trying to make this like actually have some programming stuff. And I'm going to call it. There you go. There's a bog simple Node app. So I have Node installed. So if I run that, I see something like that, right? Well, what if you didn't have Node installed? I don't even know which version I'm currently on right now. 28.1, what if the other one is using some incompatible version like, I don't know, Node 12? So those are the kinds of dependency issues that we run into. If I want to Dockerize this, I'm going to make a Docker file, no extension, capital D, the whole bit. So at this point, doesn't super matter what it is, but you should have some kind of Node app that looks like that. And you should have an empty Docker file, capital D, no extensions. I'll give you a sec to catch up. All right. So let's take a look at this Docker file. So in here, first thing that's at the top of every Docker file is like, what's the basis for this? It's always some kind of Linux computer, but sometimes they've got stuff added on top of them. Like I could start with a bare bones computer and install and set up Node myself. Waste of time. The Node team already does that for me. So I can say from Node, and then it's going to want some kind of version tag. Otherwise, it'll just go with whatever the latest was. So I can do that. I'm going to specify from Node 20. And that is just like this. If I look for like the official Node image, what happens when I do Node 20? Well, that one right there, that's saying all of these are synonyms. So 20 is going to run this like base Docker file and all those commands and install all the Node dependencies and do all that kind of stuff for me. So that's my starting place. And then what I want to do is copy the index.js file from the folder that I'm currently in into the container. Where am I in the container? I don't know. So I am going to set a working dir of /app. If this doesn't exist, it makes it. There are some images where like there are folders with specific locations that you can copy things into. Like for example, there's an Nginx image. And it's like, if you put any files in this folder, we'll serve them up over HTTP. Otherwise, it helps to specify something. Otherwise, a lot of the time you just end up dumping all of this in the in like the root directory. Just makes debugging a little bit messier. So I'm working out of there. I copy this from my computer into the Docker container. And then whenever I run this, I want to run node index.js like that. And something you'll see Docker folks do a lot is they'll put these in square brackets and quotes. It's actually the same thing, and in most cases, it ends up being the exact same command. But the few places where like that doesn't work, like especially if you're chaining commands and stuff, it can get a little bit gnarly to debug. And so if you're going to cargo cult something, that's probably a good one to cargo cult. But really is the same thing as just doing that. Node.js. All right, cool. So these are the instructions for how to build a Docker image that then we can make into a container. So to build this, just those two files. Index looks like that. Docker file looks like that. I'm going to run docker build. And then the only things we have to have a tag. That's how it's going to uniquely identify this Docker file across our computer. Because like the Docker images and stuff are stored globally on your computer, not like in this folder like Node modules is. So I'll call this hello world sunrun. And then it goes, the only other argument to this is in what folder is your Docker file? The one that I'm currently in. So let's put the dot. And then it's going through that Docker file. It's making sure that I have this base image downloaded. And then it's running each of these instructions that I had. And if we look over in like the Docker desktop thing, I have my hello world sunrun right there. I can also see that on the command line if I do like docker image ls right there. So now I have this template. That's the image part. It's a template. If I want to actually run it, do docker run hello world sunrun. Hey, Doesn't matter if I have Node installed, doesn't matter if I have the wrong version. It's not possible for the Node modules to like get out of sync. If it works in that image, works anywhere that runs Docker. And yeah, that gets arbitrarily complex. We could have 20 different containers that are all networked together, and these things are sharing some data, and these ones aren't. They can be different languages, runtimes, all kinds of stuff, and they're isolated and repeatable. So, hoping you followed along with me, but you've just built and run a Docker container. Well done. So last time I did this workshop, a very good question that I got was like, what are the trade-offs with this? This sounds so good. Why aren't we doing this all the time? So a couple considerations with this. It is actually this good, and it's why it's like kind of taken over the infrastructure world. But debugging Docker stuff sucks. It just does. When you have the images working, when your build pipeline, all this stuff is working correctly, it's an absolute dream, and you run Docker Compose up and you get everything else for free. When something goes wrong and you have to actually get into the containers, it is a massive pain in the ass. Now, it kind of is with everything that like you would be doing infrastructure-wise. But the Docker mental model, much like the mental model for Git, is so coupled to the implementation that it took me a lot of years to get comfortable debugging these containers. Using them, you've already done it. It doesn't take very long to learn. Getting into the nuts and bolts and going, oh yeah, well the syntax for that file changed and now we do it this way. That stuff is a nightmare. It has been getting better, especially in the last couple of years, but still kind of rough. Another consideration is I mentioned that Docker Desktop is a commercial product that has licensing concerns. So that VM that we're running Docker Engine on top of for Mac, as of like 2 years ago, 3 years ago, somewhere in there, isn't free for enterprises to use anymore. And it's a big one. It's like for every user in your organization or something like that, there's like some amount. And so like it's a consideration. There are like an increasing number of even like Mac-friendly alternatives to Docker Desktop, but definitely something you don't want to get popped by. And let's see, other trade-offs. The files are big. Like, so if I take a look at how big a Docker container is, I mean, check them out. Those are pretty gnarly. That can, you can literally fill up your hard drive. So, I mean, this is just playing around the last few days. It is not difficult to get 500 gigabytes of Docker images pretty quickly. It's also not hard to prune them. It can be a little slow to push them across the network. And so a lot of the times you'll like build it locally, you'll send the Docker file somewhere else and they'll build it locally because it'll be faster than trying to send them, 20 gigabytes of Docker containers. There's a consideration. On the whole, though, they're just good. It's giving us this like modularity that we already have been able to enjoy at like the application level with modules and classes and all that kind of stuff. It's getting us that at the application level without needing to fake out CPU and RAM and all these concerns that really don't have that much to do with how our application runs. And other than that, I think that was Docker 101. We described Docker, we built and run containers. Next step from here is getting into Docker Compose and talking about how we have these containers talk to each other, how we like share some of our file folders with a container so that, for example, when you save the code on your computer, that automatically happens inside of the container without having to rebuild it. And making sure that these things have ports open so that if they're serving up HTTP traffic, that you can actually see it on your computer, and a whole lot more. But in the meantime, enjoy your new knowledge. Cheers.